Alright, so let us solve your SA number 2. This is for problem number 1. If 30 liters of nitrogen at 600 mm mercury are compressed to 500 mm mercury at constant temperature, what is the new volume? So let us identify the given or the factors needed here to solve the new volume. So we have our V sub 1, which is 30 liters. Our P sub 1, or the initial pressure, is 600 mm of mercury. Our V sub 2 is unknown. Our P sub 2 is 500 millimeters of mercury. Alright, so the formula is given as P1 B1 is equals to P2 B2. So we just plug in the values here. So for our P1, we have 600 millimeters of mercury multiplied by V1, which is 30 liters, is equals to our P2 is 500 multiplied by our V sub 2. Right? Since we want to solve for V sub 2, we want to remove the 500 millimeter mercury on this side of the equation. So we can do that by dividing both sides by this value. So also on this side, this millimeter Ag, so we can cancel this. So this one, okay, so this one. Now we multiply these two together and then divide it by 500, and then our V sub 2 will give us 36 liters. Okay, so this is our new volume. Right, problem number 2. If I have 2 liters of gas in a compressor at a pressure of 1.5 atmosphere, what will the new pressure inside the compressor be if I compress the gas until its volume is 4.8 liters? So our V1 is 2 liters of gas. Our P1 is 1.5 atmosphere. Okay, that's the initial. No, these are the initial. For B sub 2, we have 4.8 liters. Okay, P1, rather P2 is unknown, right? So this is another Boyle's law. So this is also given as P1 B1, which is equals to P2 B sub 2. So now we just plug in the value for our P1, which is 1.5 atm per atmosphere, multiplied by our V sub 1, our initial, it's 2 liters, is equals to our P2, that is unknown, multiplied by our volume number 2, or the final, that is 4.8 liters. So just like the first one, right, we want to remove this one. Okay, so we divide both sides by 4.8 liters. 4.8 liters. So we can now cancel this. Okay, also this one and this one. So the answer here is 0.625 atmosphere. Right? So this is our final answer. Alright, let's go to problem number 3. Solve for the decrease in temperature when an 8 liter air at 20 degrees Celsius is compressed to 6 liters. Okay, so let's write down the factors here, or the given. We have V sub 1. Our V sub 1 is 8 liters, or volume 1. Our temperature, V sub 1, is 20 degrees Celsius. So since we're dealing with ideal gas, we have to consider the Kelvin. So we have to add 273 Kelvin to this 20 degrees Celsius. Okay, so we have 293 Kelvin. So this will be our temperature, or T sub 1. Now our V sub 2 is equals to 6 liters, and our T2, that is our unknown. Right, so Charles' law is given by V1 T1 is equals to V2 over by T sub 2, or it can also be given as V1 T2 is equals to V2 T1. So we just have to cross multiply this to have this, right? Now you can use this, then plug in the plug in the values. So for V1 we have 8 liters multiplied by 293 Kelvin, which is, and then equals to our V2 is 6 liters multiplied by T sub 2. Okay, so since T sub 2 is our unknown, we want to remove this from this equation. So how do we do that? We divide both sides by 6 liters so that we can cancel this, the liter here as well as here, right? So now we have T2 is equals to the product of 8 liters, or 8 and 293 divided by 6. That gives us 219.75 Kelvin. So since the problem did not ask for the equivalent in Celsius, so this will be our final answer. Right, problem number 4, another Boyle's law. What is the required pressure to compress 50 liters of air at 1 atmosphere into a cylinder whose volume is 10 liters? So the given here are the following: V sub 1, which is equals to 50 liters. Pressure 1, or the initial pressure, is 1 atmosphere, right? And then volume 2 is 10 liters. So pressure 2 is our unknown, right? So Boyle's law is given as P1 V1 equals to P2 V sub 2. Okay, let's plug in the values. So this is P1 is 1 atmosphere multiplied by V1, which is 50 liters, equals to, okay, P2 V2. Okay, we have our P2 as our unknown multiplied by the volume 2, which is 10 liters. Now we want to remove the 10 liters here, so we can do that by dividing both sides of the equation by 10 liters. 10 liters here, so we can cancel this. So remove the liters because they are the same. We now have P2 is equals to the product of 1 times 50 divided by 10. That gives us 5 atmosphere.